Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com, and this video is another in my series of practice sessions for the RHCSA certification. And what I thought about doing for the next few objectives for operate running systems and the understand and use essential tools objectives, I did pretty much separate videos for each of the sub-objectives. But when I start looking at configure local storage, I'm reading the objectives, and it seems to make more sense to do a video just on configure local storage than separate videos for each of the individual parts. And so that's what I'm going to do for you today. Just a reminder, these aren't necessarily intended to be authoritative information because I'm still in my learning process for the RHCSA exam, but I am trying to give you some accurate information. As always, if you enjoyed the video, make sure you click like and subscribe to the channel, ring the bell when you do. Feel free to leave comments with questions. I'll answer to the best of my ability, or if I get something wrong, feel free to comment about that, because A, I want to make sure that I'm thinking of stuff right, and B, it'll help the other folks that are watching this video to get accurate information as well. So within configure local storage, we have list, create, and delete partitions on MBR and GPT disks, create and remove physical volumes, assign physical volumes to volume groups, create and delete logical volumes, configure file systems to mount at boot with universally unique ID, the UUID or label, and add new partitions and logical volumes, and swap to a system non-destructively. So I think within a video I can cover all of this, and it won't be too terribly long. So let's start with the creation of our disks. So there are two utilities that I typically use for this. You have fdisk and gdisk. Fdisk I would use for MBR, and gdisk I would use for GPT. There's also gparted, or maybe it's just parted. I can't remember off the top of my head. That's the utility that I really haven't used much. Perhaps one day I'll get into it more, but fdisk and gdisk typically get the job done for me. I'm going to go ahead and sudo into root, because dealing with disks, you're pretty much going to need to have root access, and I don't feel like writing sudo for every command that I have. So let's go into the dev directory, and you see here I've added to this virtual machine some block devices, VDB, VDC, and VDD. A lot of times a command that I will use is lsblock or lsblk, and that'll show me some block devices that I have. I did a 5, a 10, and a 15 gig disk. So we're going to start with MBR as far as making partitions, and that stands for Master Boot Record. That's been around since the beginning of time. And the thing with its partitions, you can have a total of four primary partitions. If you need more than that, you would make one of the partitions an extended partition, and then make logical partitions on that. And I can't remember what the limit of logical partitions. I'm going to think 16, but don't hold me to that. A lot of systems today are going to be using GPT, or I think it's a GUID partition table. It gives you 128 partitions. Can also handle devices that are greater than, or partitions that are greater than 2 terabytes in size. That's another limitation of MBR. And I'm pretty sure systems that are booting from UEFI, the boot disk has to be GPT partition for UEFI as well. So on MBR, the tool we're going to use is fdisk, which I believe is going to be installed. I think it's pretty much on every Linux system there is. And let's do VDB for this. So I'm going to do fdisk, if I can spell, dev VDB. And that opens the utility. M will give you a listing of all of the commands that you can use. But the first thing I'm going to do, it talks about list, create, and delete partitions. We're going to use the P command, which is going to give us the information about the disk, as well as if there are any partitions, list them. We don't have any partitions on this particular disk, we're about to make them. So to create a partition, we're going to do N for new, and it's going to ask if we want to make a primary or extended partition. We're going to go and do a primary partition for this. And It's going to ask us what number do we want to make the partition. We're just going to stick to the default 1. Then it'll ask where the first sector is. And notice that the sector, it's at 2048. The areas before that, that's where the master boot record information lives. So we're just going to keep the default for that. And then for the last sector, this is where we're going to determine size of what our partition will be. You can either do this in terms of sectors themselves, and I can't remember what the sector size is off the top of my head, or you can do it with the actual data size that you want. That's what I typically do. So since this is a 5 GB partition, I'm just going to do this in megabytes. So I'm going to say plus 500 M for megabytes, and it will create a new partition of type Linux and size of 500 megabytes. Now notice it talks about type. I'm going to, I believe it's the L key, the L command that I want for that. Yep, and that's going to list the different file types for that. 83 is just Linux. If this partition is eventually going to be used for LVM, we would want to change that to 8E. And then depending on how this partition is going to be used, like if you're going to make it a FAT16 partition, you would use option 6, on and on and on. So I'm going to use the M command because I can't remember off the top of my head. Yeah, that's list known partition types. T. All right, that's what I wanted. So T is going to change the partition type. So if I wanted to do T, and then L to list all the different hex codes. If I wanted to change this from just like plain Linux, which is 83, to LVM, this is where I would do 8E for that. And it's changing the partition type from Linux to Linux LVM. Now, just in my test and messing around, I haven't seen this make a whole lot of difference between Linux and Linux LVM. But I would imagine, just as a best practice, you know, this is something that you can set. Probably wise to go ahead and set that. So at this point, we've made the partition, but it doesn't actually exist yet. Anything that you do with fdisk, you eventually have to write it to a disk, and we will use the W command to write it. And it says partition table has been altered. Another command that you want to run, even though most times I have seen the your Linux system figure out that partition table's been enabled, but it's a good idea to run a command called part probe. And what that is going to tell the operating system to reread all of the partitions, make sure that we find it. So if I do lsblk, we see there's a partition there. If I were to list the dev directory, we see VDB1. VDB is the block device. VDB1, or VDB1 is also a block device, but it's a partition of VDB. So that's creating your partition. If I were to go back into fdisk, the VDB, and I were to do the P command now, you see that the VDB1 partition is listed there. And thus for the listing part of that. To delete a partition, we will do the D, and there's only one partition on this, and so it shows that it's been deleted. But you also still have to do the write, and then part probe, and we see that the partition is now gone. gdisk works pretty much the exact same way. So let's say for VDC, we want to use we want to make that a GPT disk. So gdisk, I'm pretty sure gdisk is installed. Yep, it's installed. I think on the minimal installation you have to you'll need to install the gdisk package, but for the server with GUI installation, it's already there. So same kind of thing, gdisk dev vdc. Technically don't need to put the dev part since I'm already in that directory, but it's a habit. And you'll see that the interface is very similar. If I were to do question mark, it's going to give me all of my commands, and you'll see that commands pretty much have the same meaning between fdisk and gdisk. I can do P for partition table. Of course, we don't have any partitions here. N to make a new one. This time, notice it tells us we can do up to 128, but we're just going to do the 1. First sector works the same way, and so I'm going to just keep the default for there. For size, let's make this, since I have 10 gigs to work with, let's make this a 5 gig partition. Here, unlike with FDisk, we have to tell it which hex code to use, and by default it's going to use just the Linux file system, but the hex codes are a little bit different for GDisk. Do capital L to see them all, and what I have found is most of them add 2 zeros after it. So if I want Linux LVM, let's find that here on the list. I know it's going to be 8E00, but just see if we can actually find it on the list here. There it is, 8E00 for Linux LVM. So 8E00. Oh wait, press enter key to see more codes. Yep. Just change it to Linux. So I believe T is going to let us do that. Yep, 8E00. That's been changed to Linux LVM. Just like before, do the right. It's going to warn you that this is going to overwrite existing partitions. That's one thing. If you, let's say you have a disk that's MBR, you've used FDisk on it, and then you run GDisk, I'm pretty sure GDisk is going to automatically try to make that partition a GPT partition, and that will mess with the MBR partition and make it unusable. Not 100% sure on that, but that is what I have heard. I haven't tried it myself. We do want to proceed, and it's writing the new partition table. We'll do part probe, and let's do ls block, and there's our partition. If I do gdisk again for dev vdc, do the p command, that's listing the partition. Partition number 1 starts on sector 2048, ends on this particular sector. I guess it's what? 10,487,807, and it's 5 gigs in size. And we see the code for Linux LVM. We'll quit to exit out of that. So when we're working with our storage and such, you don't always partition everything. Partitioning, one of the ideas behind doing it is that if something happens to a particular partition, you don't necessarily lose the entire disk. Just that one partition is causing a problem. In particular, running out of space. You know, let's say that you have this particular application is using this particular partition. It fills up. Well, your other applications, once that partition fills up, they're probably not going to be affected that much. What I typically find is, rather than using a bunch of different partitions, what we typically start doing is using LVM for things. And LVM, Logical Volume Manager, what that's going to do for us is give you kind of a layer of abstraction that is much more malleable than working with the individual partitions themselves, where you can make some changes and such. So diving into that, let's go back. I'm actually going to, let's use VDC. I'm pretty sure VDC has 15 gigs, or VDD rather. So I like using GPT stuff. So we're going to do gdisk dev VDD. You do not have to make a partition for what we're going to do. I'm doing it, just get another practice at doing gdisk, but I have done this before just on the block device itself. I'm not sure what the best practice is though on that. I've read some say no, you need to do it on a part. You need to use, even if you're wanting to use an entire block device, make a partition and then do LVM. I've read some things as like just use the block device. I've seen it work well for both. So we're going to new partition. Keep the defaults, first sector, last sector. We're going to use the entire block device for this, 8E00 for LVM, and we have change of partition to Linux LVM. We're going to write that, yes, and we'll part probe. And there we go. So LVM kind of goes in tiers. You have to identify physical volumes that you're going to use for Logical Volume Manager. Then the physical volumes are put into a volume group, which that creates a pool of storage for you to make a logical volume, which then presents another block device for you to then put a file system on. So let's go through that. So we've made our physical disk, the VDD1, and so to mark a block device for being a physical volume with LVM, we're going to use PV create and then the device name. All right, and that is now successfully made. And if we want to view that, we can do PV display, and that shows us our physical volumes. We have VDA2, that's a part of the default installation, but the one that we're working with is VDD1. So we have a physical volume. Now we need to put it into a volume group, because from the volume group is where we're going to have the storage for what will be our logical volume. So to create a volume group, we do VG create. We're going to give it a name. I'm going to call it test VG, and then we tell the volume group what physical volumes are going to be a part of it, and that will be dev VDD1. All right, volume group test VG successfully created. If I do VG display, scroll here, we see our test VG has about 15 gigs of size. And notice you see this thing about PE. You have this idea of physical extents, which I can't give you a whole lot of detailed information about, but think of it kind of like sectors on your hard disk, and each physical extent is 4 megabytes. And so if you were, let's say you have a 1 megabyte thing that you're storing here, the actual physical storage size that's going to be used is 4, because that's, you know, the most basic block that we have here. So got our volume group, and it has about 15 gigs available. Now I mentioned the fact that we had to mark physical volumes to be used with LVM. Now if I do ls block, you see that we still have our VDC1 as a partition. If I were to try to add that block device to our volume group, it's probably not going to work. So let's see what happens here. If we do VG extend, and our volume group name, which is test VG, and I try to add dev VDC1, I think it's going to yell at me. Huh. Ah, I see what it did. Notice the line here. Physical volume dev VDC1 was successfully created. So what it did was realize, hey, this hasn't been marked for being a physical volume with LVM. We're going to go ahead and mark it for you and then add it to the test VG. I was totally expecting that to error out and say, hey, you need to mark this as a physical volume. So if we were to VG display again, we should see it has about 20 gigs. Yeah, test VG 19.99 gigs available. So we have our volume group. Now we need to make a logical volume. So with that, LV create, we're going to give it a name, and the name we're going to give this is test LV. We're going to give it a size. You can do this in a couple different ways. Dash lowercase l is going to be for the extent size, so the number of those extents that you want to allocate to this. You can also use that to do a particular percentage. If you want to, of your free space, you want to just don't really care about the exact number, but you want to give 25% free to this, you would do dash L, and then I believe it is 25% sign capital FREE, and all of those letters are capital. Or you can do dash uppercase L, and much like when we were working with FDisk and GDisk, give the exact size that we want this to be. I'm going to do that. So I know I have about 20 gigs to work with. Let's make this a 5 gig logical volume. And then we need to tell it what volume group we're going to be using for this storage. And that's the test VG volume group. And it says logical volume test LV has been successfully created. So if I were to ls block, we now see that we have the test LV block device available to us, and that is 5 gigs large. If I were to go and take a look at dev, where this device lives in dev is, you can see it under test VG. There's our test LV. And if I were to do ls-l, we see that that's really a symlink to another device, the DM-2. That you're not going to be working with that much, because quite frankly, when we do our file systems, I like to use UUID whenever possible, because that eliminates confusion. But just to let you know, I mean, this device is a symlink to some other particular thing, and that's where that DM2, and I think that deals with device mapper, which I can't tell you real details about how device mapper works. I just know that is a part of the LVM system and such. So looking at the objectives, we have created physical volumes, we have assigned physical volumes to volume group, we have created logical volumes. So let's go backwards. Let's do some deletion. So if we wanted to, so we have our logical volume, LV display, and there is our logical volume. If we wanted to get rid of this logical volume, we will do LV remove. And I'm not sure if this will just accept the name. I don't think it will. Yeah, so we need to do LV remove and then the path. So that's test VG, test LV. Am I really sure I want to remove that? Yes, I am. And it's gone. If I do ls blk, we see that it's gone from there. Now, if we need, we can remove a physical volume as well. Let's say that we don't want that VDC1 to still be a part of the volume group. Well, let's see if we can just blow away VDC1. So just like we create a physical volume, we're going to do PV remove dev VDC1. And it's going to complain because it's currently being used by a volume group, and it's not going to let you just yank that out. And it even tells you what command you need to do, VG reduce. So we're going to do that, VG reduce. The name of our volume group is test VG, and we'll list the physical device. All right, so that's now gone from test VG. We're to do VG display. You see that we're back to about 15 gigs of size. We took away that 5 gigabyte partition from it. Now we can do PV remove dev VDC1, and it removes it from being a physical volume. So that covers the removing aspects of those. Next, it talks about mounting file systems at boot with universally unique ID or label. So what we need to do is make a file system. So if I were to do, let's make another logical volume, and we'll do this with the XFS file system. So LV create, and we're going to name it XFS LV. We'll give it a size. See, we have 15 gigs to work with now, so we'll just make it 2 gigabytes in size, and test VG is the storage pool that we're using for this. All right, ls blk. There's our XFS underscore LV for that logical volume. So what we want to do is put a file system on it, and that good old Make.fs will do fine for that. So we're going to do mkfs. I like doing .xfs. And then the path to the device. So dev test vg and then xfs lv. Now if we were to do the block ID command, we see that this particular file system exists with type XFS. Alright, so if we wanted to mount that persistently, let's make a directory within mount mnt. We're going to call it XFS test. So we use RHCSA tab for that, and I'm kind of blowing through this because I'm assuming that that since there are other objectives that really go into some more detail with file systems, I'm kind of saving the details of this for that particular thing. But to mount persistently, we're going to be using RHCSA tab. So I'm going to VI into RHCSA tab. And a little trick that I've learned. Now, since I'm in the GUI environment, I could easily have made another terminal window and VI into it, or open this in gedit or something. But if I was in just a console environment and I wanted to make this work and it and be able to get that UUID easily and not have to memorize it, here's a little command you can use. $lowercase r is going to write whatever command that we're going to do into VI. I'm going to do exclamation point, which allows me to run a command, just a regular bash command kind of outside of VI. I'm going to do block ID. And notice this gives us all of that output. So if I wanted to, I'm going to look for our LV logical volume, and that's it here, the dev mapper. So let me DD some lines away. So I'm left with this. Go into insert mode, and here is my UUID, all nice and there for me without having to memorize that string of characters. So we're going to mount this to MNT, what I call it, XFS test, right? File system is XFS. We're just going to keep the defaults and no crash dump, no checking for file system, and we'll exit RHCSA tab. Now, to check to see if this is actually going to work without rebooting the system, what we can do is mount -A, which is going to read everything in RHCSA tab, and dfh, and we see that our volume is there, and it has been mounted to XFS test. Now, the neat thing about that is that keeps us from having to take the time to reboot to be able to see if this is going to happen persistently. And since it's in FS tab and it was able to be mounted with mount-A, that has worked. Now, there are a couple of scenarios where that might not be 100% true. In particular, if you're doing stuff with Stratus and VDO, and when I get to those particular topics, I'll show you what I'm talking about with that. But for just regular old file systems, mount-A is an easy way to test to see if your persistence is going to work. Now, we can also do this with a label. And so let's make another logical volume. So LV create. We're going to name this XFS label LV. Let's make it 2 gigs as well, and we're using test VG as our group. So we have XFS label LV. I want to put a file system on it, so mkfs.xfs, and I know where this is going to be located. So we've made our file system, and if we want to add a label to this file system, what we need to do is, I believe it's XFS admin. I want to think it's -L, capital L for label. We're going to find out. So we're going to label this XFS test. We'll do it all in all caps. And then the file system. So dev test vg XFS label LV. No, XFS admin. That's what I need. There we go, and it writes a new label. So if we were to go back to RHCSA tab, and we're going to do the same kind of thing. Oh, wait, I need to, well, I can do that in a moment. This is one cool thing about VI. So I'm going to go ahead and move to another line here. Exclamation point. Oops, I need to get back to command mode. There we go. Exclamation point runs commands. So I can make dir mount XFS label test. Pretty sure that will do what I want. And let's try exclamation point ls mnt. Do what I want. Let's go out of VI. Yeah, it did. It made my directory. Yay, the power of VI. All hell VI, our Lord and Savior. No, kidding. You know, you have the whole nano versus VI thing. I don't hate nano. I just tend to use VI because it's everywhere. So let's go back to FS tab. Now that we have our directory. And we're going to do the same little trick. I'm going to do :R block ID. Technically didn't have to do that because I knew what my label was, but it allows me to be a little lazy with this. And so rather than using UUID, we'll simply use label. Personally, I would probably be using UUID all the time, but one of the objectives is to use label. So we'll delete this stuff here. We are mounting it to XFS label test. I think that's what I did that as. XFS file system defaults 00. Nope, test is capitalized. So let's go back into RHCSA tab. And let's capitalize that. Mount -A df-h, and there we go. You can do the same with ext4. I believe the command for that is going to be tune to fs, and what you would do with the tune to fs is I think it's also -L, and you would simply do the label for the ext4 file system. Actually, let me check that real quick. Tune to fs. Yeah, volume label. So for your ext4, that'll work for that. I'm just using XFS for this example here. So we have configured systems to mount file boot with universally unique IDs and labels. That's pretty easy. And then last, we have to add new partitions and logical volumes and swap to system non-destructively. So we don't want to lose any data, and we want to add some stuff. Well, we've already demonstrated adding a logical volume. We did that for the excuse me, XFS label test. If we want to add a partition, let's go back to the VDC. We'll do fdisk dev VDC. If I were to do P, we have the one partition there, and we simply repeat the process. We give it a VDC. I think I used gdisk on that at some point. Yeah, I must have. So let me quit out of this. Yep, must have done that. So it's VDB, I think we did fdisk on. Well, we'll use gdisk, that's fine. And let's completely get out of this. Gdisk dev VDC. There we go. Print the partition table. Let's make a new one. We'll just use partition number 2. First sector, by default, is going to start at the next available sector after the original partition. And then last sector, we'll just do 1 gig for that. We're going to keep Linux file system. Write it. Yes. Got the right GPT data. This will override existing partitions. Well, let's see what happens here. ls block. Looks like we still have our partition there, and we have VDC2. So that error message was kind of scary. So let's put this to the test real quick. We'll do ext4 this time. So make fs ext4 dev VDC1, and let's mount that. Make an ext4 folder, and I don't think we have to do the T for this. I think it should be able to figure it out. So we want to mount dev VDC1 to mnt ext4 df-h. Now this would not survive a reboot because we have not added it to etc fs tab. But for the purpose of this little test, it's going to work. We see that that's mounted. Let's echo test file to ext4 and test.txt. And let's cat that. mnt ext4 test.txt. There's our file. So we're going to make another partition on VDC and see if that error message is true, and it's going to wipe everything out. I don't think it is though, but let's just see. So gdisk dev VDC, and we want to make a new partition. This will be number 3. Keep that default. We'll make another 1 gigabyte partition. Keep it as Linux. Write it. We get the scary message. Yes. And table. Still using the old partition table. So new table will be used at next reboot or after you run part probe. Okay, so let's do part probe. All right. df-h. That still appears there. ls block. That still appears there. And let's see if our file is still there. Cat mnt ext4 test.txt, and there it is. So big scary message. However, it did not remove the data, and we successfully added a new partition per the objective. So the last thing we have to do is make swap space. Now there are a couple of ways of doing this. I'm going to do this using a partition rather than making a swap file, but the same idea would work with our swap file. So we have our partition VDC3 that we're not using. It is 1 gigabyte of space. Let's do free-mh, and that shows us we currently have a total of 2 gigs of swap space. To mark a partition to be able to be used as swap, we're going to do mkswap dev VDC3. All right, and then to make it be used for swap space, swap on dev VDC3. I don't think I need to do -a, but we'll see. Swap on, and let's do free-mh, and now we have 3 gigabytes of swap. If we want to remove the swap, swap off dev VDC3 and free-mh, we're back to 2 gigs of swap. So we've added that non-destructively, but remember, everything we need to do, we have to be able to do persistently. So here's how this is going to work for our for our FS tab, just for kicks, block ID. And notice we do actually have a UUID for the swap. But let's go into CFS tab. And we see our swap. So we can do this by UUID, or we can do the device name. Just to do something different, I'll do it by device name. So dev VDC, I think it was 3 that we do. That's going to be swap. Or rather, we're quote mounting it to swap. It is file system type swap, defaults 00. I think that's what I was using, VDC3. So just like mount-A to test if the persistence is going to work without having to reboot, we can do swap on -A. It didn't complain. Free MH, and there we see our 3 gigs of swap. So this actually was a lot to cover in one video. And I guess maybe in retrospect I should split them up into separate videos. I'll probably do that for the create and configure file systems. Actually, as a matter of fact, I know I'm going to do that because I want to do separate things on VDO and Stratus. So for configuring local storage, this video we covered the basics of doing all of the listed objectives. I myself feel fairly confident about it. If you enjoyed the video, make sure you click like, also subscribe to the channel, ring the bell. Feel free to share this with others if you think it would be useful for them. Thanks for taking the time to watch. I know this was a long one, and I'll see you the next time.